Okay, kids, I hope you're home and well, and likewise with your family. So, this is Geraldi trying to do her first teaching video. Hold on to your seats. This is going to be wild. Anyhow, how to start any great lesson is to have the long-awaited and much-missed chemistry joke of the day. So, with that said, why are chemists so great at solving problems? Come on. Think about the unit that we're doing. You now have 5, 4, 3, 2, 1. And the answer is because they have all the solutions. Ha 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 ha. Okay, enough of that. Now we are going to go right into the lesson. You should be on page 10 of your note packet that was called Solutions. I had uploaded the answer key to this, but if you still have your note packet, that would be a great thing to have as you go along. What we're doing now, or I should actually step back a moment and take a look. We finished looking at how to use the table G. And again, remember, this was either solids, represented by the direct lines, or gases, represented by the indirect lines, and how much was dissolved per 100 grams of water. So now we want to look at why do some things dissolve and other things don't. So the three factors that we have are, and the first one is the nature of the solute and the solvent. We're not going to actually look at this animation. I'm going to guide you to look at something a little bit later. The nature of the solute, let's remember the solute is the thing that gets dissolved and the solvent is the thing that is dissolved. So we have these terms that you should remember from the previous unit on bonding, where we have the words nonpolar, polar, and then, of course, ionic. So when we talk about nonpolar solute, the important thing to realize, it means that it is not pulling in a certain direction. And these would typically be for your covalent compounds. Okay, if you have a nonpolar solute in a nonpolar solvent, it is soluble. Soluble means, again, able to be dissolved. So we have this very important statement, which is like dissolves like. So if you have a nonpolar solute and a nonpolar solvent, it will be soluble. Conversely, if you have the nonpolar solute with the polar solvent, meaning that it's not an equal distribution of charge, then it is insoluble, meaning it does not dissolve. And the same is true when the two polarities are reversed. When you have a polar solute in a nonpolar solvent, it's insoluble. And when you have polar solute with polar solvent, it is soluble. Again, soluble just means it is able to dissolve. Now, ionic. Remember when we talk about ionic, that the charges are so strong that one of the atoms actually pulls the outer electrons away from the other atom. Okay? So you have to think of ionic as being a supercharged or a polar solute that's on steroids. So if you have ionic solute with nonpolar solvent, it would be insoluble. And if you have an ionic solute with a polar, it would be soluble. So I just want you to think of ionic as superpolar solute. Okay? So, I don't have handy the styrofoam demonstration. However, you do know that when water and styrofoam gets thrown into water, it stays in the water for hundreds and hundreds of years. So styrofoam does not dissolve in water. So nothing happens. Okay. However, so we both know that that means that both of these were in the same nature, meaning they're both either polar or they're both either nonpolar. However, we should remember that water is a polar molecule. Therefore, styrofoam would also be a polar molecule. So there is that like dissolving like. Acetone is a different story. Acetone is just basically nail polish remover. If you go to YouTube and you Google acetone dissolves in styrofoam, you can see a very cool demonstration. But what happens is the styrofoam quickly dissolves. Okay, I am going to end this little mini lesson right here, and a little later I will pick up with factor number 2, temperature.